Let's think about people efficiency in a program. Whenever I assign a variable value into a variable that is a people 1, main method I do not know yet. When I declare and instantiate an array that is a people 1. This is a read array list. I do not know what is read array method efficiency, so not yet. Mean method I do not know yet. Standard deviation I do not know yet. Print, this one is also special method, not the system out the print. So I do not know yet. So I'm going to look at the read array first. When I look at the read array, at the beginning there is just a variable, initialize a variable, so just the big 1. Then J option pane, the show input dialog, I do not know, this is a built-in method. In that case, I just assume that it's fast enough, so big 1. Then while, there's a while loop, and this while loop is happening until the user does not put -1. So until user puts -1 to stop. That means number of user input height. So I can say this while loop itself is a big N. It is repeating until user input the valid height number. Then in the if statement, it is just comparing variable and variable that is big 1. Then resize method. This is the method, so I need to check what resize method means. So I'm going to check resize method. If I look at the resize method, first, if n is 2, and that is just a big 1, compare variable. 2 times another variable is big 1, just a 1 multiplication. And instantiate array is just a big 1. Does that mean I do not know? And this is also built-in method. I assume this is fast enough. And in the for loop, this one is assigning only value into the another array that is big 1. So because the for loop is regular for loop is I is increasing by 1, so big N. This for loop is big N. And return new list is big 1. So it's a 1 plus 1 plus 1 plus n plus 1. So the whole method efficiency is big N. I'm going to go back. So if I see here, now resize becomes a big N. I do not know how many times the resize will be called, but n is increasing by 1 each time, so I can say until n reaches list.length. So I can assume this one is doing each time until n is greater than or equal to length. So big N will be counted as it will be run, executed each time. Then big N goes to the each time. Then list n equals height, and it's just a big 1. And plus is a big 1. When I ask to the user by using the built-in method, I assume that it's a big 1. So this while loop is big N square. Then there is another resize method that is big N. And return list is big 1. So I can say this whole method read array is big N square. So I can write big N square in the main method. Now, how about the min method? The min method in the back page. I'm going to look at min method. Initialize variable is big 1 and another variable big 1. In the for loop, I is increasing by 1. And assigning just list I is a big 1. And for loop is a big N for loop. Then it is doing big 1 each time, so big N. Then sum is a variable divided by n. N is also a variable, so it is doing only one division, that is a big 1. So min method is a big N. 1 plus 1 plus n plus 1. If I come back to the main, I can fill out now min method calling print min, that is big N. Now how about standard deviation? In the standard deviation, there is a variable set that is a big 1. Another variable assignment big 1. And this for loop is I is increasing by 1 until n, so big N. And inside of the for loop, there is a list I minus min method that is big O n. So inside of the for loop statement is big O n. But different times different is just one multiplication that is big O 1. So inside of the for loop, there's a big O n. So this whole for loop becomes big O n square. So 1 plus 1 plus n square. Also, as the square root is a built-in method, and sum and n minus 1 are just a variable. I assume they are fast enough, so big O 1. I can say standard deviation is also big O n square. So I can fill out in the main method, the standard deviation is big O n square. Now, how about the print method? In the print method, first assignment of the variable is big O 1. There's a regular for loop big O n. Then in the print, list I is big O 1. And calling list I is another big O 1. Minus, that is the first calling in this second line. And min method is big O n. So you do list I minus min first. So minus is one calculation that is big O 1. So up to here in the parenthesis is 1 plus n plus 1. So that is big O n. Then standard deviation is big O n squared. So after you are doing the list minus the min list, then pulling standard deviation, get the number. After that, division. Division is just big O 1, one calculation. So this one looks like n plus n squared plus 1. Quadratic, so big O n squared. So inside of the for loop, each time big O n squared. So this whole for loop becomes big O n cube. That means this print efficiency becomes big O n cube. If I go back to the main method, big O n cube. So this main method becomes 1 plus n squared plus n squared plus n cube. So big O cube. Why do we count only biggest one? Think about n is million. N squared is 10 to the 12th power. And cube is 10 to the 18th power. So much bigger. Even though you have like a 10 of n squared, that is still 10 to the 13th. And now reach it to the 10 to the 18th. So that's why we count only the biggest one.